everybody. Sorry, let me get situated. All right. So in the first problem, they want us to find an angle. And it just so happens that we know the side that's across from this angle. And we have another pair. We have an angle, we have a side. So this is side, side, angle. Oh my goodness. All right, so we're going to use law of sines. So sine of A over the side that's across from it equals sine of angle 88 divided by the side that's across from it. We're going to cross multiply. And we're going to divide by 27. And in my calculator, I'm going to do sine inverse of 11 times sine of 88 divided by 27. I'm doing an inverse because I'm solving for the angle. 11 times sine of 88 divided by 27. Inversed is 24.03 degrees. Now really I should be checking for a second angle A. So if I take 24.03 and subtract it from 180, I get 155.97, which cannot be angle A because I already have angle B as 88, and those added together would be bigger than 180. I'm solving for BC in number 2, which is actually side A because it's across from angle A. So I'm going to set up my proportion again. Sine of 25 over A equals sine of 114 over 39. Again, I'm going to cross multiply. Divide both sides by sine of 114. And I don't need an inverse on this one because I'm not solving for an angle, I'm solving for a side. So I just have 39 times sine of 25, and I'm dividing by sine of 114. And that gives me 18.04. No need to check for anything else because it's an angle, or it's a side. All right, angle C and C, and then I'm looking for angle B, and I have side B. So everything's all set up for me to do my proportion. So sine of 47 over 4 equals sine of B over 23. Cross multiply. 23 times sine of 47 equals 4 times sine of B. Divide by 4. And because I have this angle I'm solving for again, I'm going to inverse. So I have sine inverse of 23 times sine of 47 divided by 4. And my calculator tells me it can't do that. So that means that angle B does not exist. This is no triangle. The C is way too short to be across from this 47-degree angle. All right, in number 4, I have a lot more work to do because the way that it's set up, I have C and C. I have B, but I'm not solving for B, I'm solving for A. So first I've got to find B. So sine of 32 over 20 equals sine of B over 29. Cross multiply. And of course I'm going to inverse because I'm solving for an angle. So sine inverse of 29 times sine of 32 divided by 20, which gives me an angle B of 50.2. So to find angle A, I just need to subtract from 180. So 180 minus the 32 minus the 50.2 gives me a 97.8. Now I might have another angle B I have to check. Ambiguous case. So I take 180 minus this 50.2, which is 129.8. So these two are going to add to 180. Now I'm going to find if I have another angle A. So 32 plus 129.8. And I need to subtract those from 180. And yes, that leaves me with 18.2 as my other A. So this is my ambiguous case. I know that this is 32 degrees. I know that across from it I have 20. I know over here I have 29. So this length right down here in green, I'm not sure of. This angle up here, I'm not sure of. This angle over here, I'm not sure of. If I found this one right there to be 50, it's actually possible that this could be 32 degrees, this could be 29, but 20 can come in like that. Then the screen length would be shorter and this angle would be obtuse. And that would be what the 129.8 would be. All right, here's the big one. Find both options for the side using the ambiguous case. So I'm given C and C. Perfect. I'm given B, but I'm not given angle B. So I got to do that first. Cross multiply. Inverse, because I'm finding an angle. So inverse sine of 33 times sine of 17 divided by 31. That gives me an angle B of 18.1. So, if C is 17 and B is 18.1, then I need to subtract from 180, and I get angle A to be 144.9. So I'm going to need to use that to find side A. Now there might be another triangle. So I have to find my other angle B. So subtract the 18.1 from 180, and that makes my other angle B 161.9. So then what's my other angle A? 17 and 161.9 subtracted from 180 only leaves me with 1.1. It's a very teeny tiny angle, but it exists. So now I know my two triangles. One is acute like this, 17, 18, and 144. And one is obtuse like this. 17 still over here, 1 up there, and then this is my 161. So what I'm finding is this side right here. So obviously one's big, it's across from 144, and then one is really small, it's across from this 1.1. So set up your law of sines. Sine of 17 over 31 equals sine of 144.9 over A. Sine of 17 over 31 equals sine of 1.1 over A. Cross multiply, no need for an inverse because we're just finding a side. So 31 times sine of 144.9 is equal to A sine of 17 divided by sine of 17. Is 60.1, no, sorry, 60.96, so 61. Cross multiply here, 31 times sine of 1.1 equals A times sine of 17 divided by sine of 17. Times sine of 1.1 divided by sine of 17 gives me a whopping 2.04. Alright, some law of cosine. So how do we know? This is side, angle, side, an included angle. So to find AC, which is actually little b, we're going to set up our law of sines. b squared equals a squared plus b squared minus 2ac cosine of angle B. So this is A, this is C, this is A, this is C, this is cosine of angle B. So notice B matches with B. All I'm going to do is put all that into my calculator. So 11 squared and 18 squared minus 2 times 11 times 18, cosine 125. Not inversed, we're not finding an angle, we're finding a side. So that's 672.136. So when I square root that, I get 25.9. In number 7, I'm actually finding an angle B, so I have to use this 28 right here. So I'm going to solve for the angle, subtracting this 11, well, subtracting these other two sides and dividing. So it's 28 squared minus 18 squared minus 12 squared divided by these, negative 2 times 18 times 12. And I'm going to cosine inverse that because I'm solving for the angle. So remember, this 28 is across from the angle I'm looking for. It goes first. Then you subtract and subtract. Everything's squared in the numerator. Then we have a divide by negative 2, and then these other two sides, the 18 and the 12. Since I'm solving for B, B goes first. And then I'm just going to cosine inverse that fraction in my calculator. So 28 squared minus 18 squared minus 12 squared divided by negative 2 times 18 times 12. Which is 137.01. All right, area. There are two formulas for area depending on what you're given. 1/2 AB sine of C, or the side one where you have to do the square root. So this one, I have side angle side, of course. So pretty easy, my formula, 1/2 times 8 times 6 times sine of 114. No inverse, not solving for an angle or anything. Just put that in your calculator. 1/2 times 8 times 6, sine of 114. On this one, I'm given all three sides. So what I can do is I can find an angle and I can do this formula if you really want to be extra. Or you can use Heron's formula, which is adding all the sides together and dividing by 2. And then taking S minus A, S minus B, S minus C. Where these are all my sides, A, B, and C. Doesn't matter, P, Q, H, K, whatever. So to get S, I'm going to add them all up. 8.7, 6, 11.5, and divide by 2. That's 13.1. Then I'm going to subtract all my sides. Doesn't matter what order. And I get 25.59. Oh, I'm not rounding to the 10th. Oh well. Meters squared. Alright, in 10 I got to do a little bit more work because I'm not given side, or side, angle, side. But the easiest thing to get is actually side, angle, side. So I have this side, I have this angle. If I find side little r, I can do it. Or you can find little p and do P, 118, and 7. It doesn't matter. I'll find R. So I have to do law of sines. So first I have to find angle Q by subtracting from 180. So 180 minus 118 minus 18 is 44. So then I have sine of 44 over 7 equals sine of 118 over R. And then you're going to cross multiply. And then R comes out to be 8.8 897. Now I can use my formula. Half, side, side, sine of the interior angle. Or I'm sorry, the included angle. So I was using these three. .62 centimeters squared. Okay, last things. Vectors. All right, dot product. So to graph this, 0, -2 is like that. And 110, 110. So I'm anticipating a negative dot product because this is an obtuse angle and my vectors are going in different directions. So to do my dot product, U is U1, U2, and V is V1, V2, and my dot product is U1, V1 plus U2, V2. So 0 times 1 plus -2 times 10 is -20. Just like I thought. It's negative because the angle's obtuse. The vectors are going in different directions. All right, angle between the vectors. So first one, if I graph 4, 1, 4, 1, something like that, 1, -4, something like that, and I find the angle. So that's the cosine inverse of, and I'm going to do my dot product in the numerator. 4 times 1 plus 1 times -4, which is 0. Now I have my magnitudes in the denominator. Square the 4, square the 1, square the 1, square the -4. If you put this in the calculator and you inverse it, you're going to get 90 degrees, which means that these vectors are orthogonal, which just means 90-degree angle. Perpendicular vectors. All right, last one, so exciting. All right, so cosine inverse of dot product in the numerator, 7 times 10, -5 times 3, magnitudes in the denominator, 7 squared is 49, -5 squared is 25, 10 squared is 100, 3 squared is 9. So I'm cosine inversing because I'm finding an angle. 70 minus 15 divided by the square root of 49 plus 25 times 52.24 degrees. Alright, so let's see if that makes sense if we graph it. So 7, -5 is something like that, and 10, 3 is something like that. Yeah, it looks good. Looks like it could be 52.